Okay, let's see how to do a t-test on Excel. Now remember, a t-test is just a test of a hypothesis. It's basically used to compare the means of two different samples to see if they're significantly different in a statistical sense. So we're going to use problem 29 as an example. Problem 29 is on page 424 of your book. I've included this data file. I've attached it to the video so that you can download it and work along with me if you'd like to do that. As always, Excel makes this really easy. Um, but in order to use the Excel function, we're going to have to do a couple of things. But anyway, um, the problem is the problem says that nationwide, we're assuming that school administrators make an average of $90,000 a year, and we've taken a sample of, I think, 25 school administrators in the state of Ohio, and we want to see if their pay is significantly more or less than the national average. Well, we could just take an average of this sample really easily using Excel. And by doing that, we could see that the average of the sample is $85,272. So, you know, we're prone to say, well, school administrators in Ohio make less than school administrators nationwide. They only make $85,000 a year. But what we want to know, since we've taken this sample, it's not every school administrator in the state of Ohio, it's a sample, and we want to make an inference about the population of school administrators. So we want to see if this difference is statistically significant or if it's due to chance, you know, just the people that we pulled at random. And so that's what a t-test is going to tell us. So the first thing we need to do in this example, or in any hypothesis test, to decide what our hypotheses are. So we can take the null hypothesis, and in every case the null hypothesis is kind of the common wisdom, or what we assume to be true. And so we're assuming that the population mean, or mu, is equal to $90,000. Okay? So the alternative hypothesis, the thing we're checking for, is whether or not these school administrators in Ohio, whether their average salary is not $90,000. It might be more or less than $90,000. We'll call that the alternative hypothesis, is that mu does not equal $90,000. Now we're not saying more or less. It could be either more or less. So therefore, this is a two-tailed test. If we were testing to see, if we were just testing that we wanted to see whether school administrators in Ohio made less than $90,000, and we didn't care if it was more, then it would be a one-tailed test. But we're looking at more or less, so it's a two-tailed test. All right? All right, now, again, your book shows you a lot of different ways to do this, but Excel will do it for you just super fast and easy. But in order for it to do it, we have to kind of fool it a little bit, because we only have one sample, and the t-test function in Excel will only consider a two-sample test. So we have to make another sample, and we'll call it a dummy sample. Oops, sorry. Wrong place. So we'll just go over here and we'll make another sample and we'll call it dummy. And we have to have at least two cells, and we'll put zeros in those two cells. So here's one sample and here's another sample. It's a dummy sample, and we're just doing that so we can confuse or trick Excel. Now what we're going to do in order to make this work is we're going to go up here where it says data. Okay. And then we're going to go over here where it says data analysis and click on that. And it gives us a bunch of, you can see that there's a bunch of different statistical tests that Excel will do for you. And it'll do several different types of t-tests, but they're always two sample tests. What we're really trying to do is a one sample t-test, but that's not an option. So we don't know what the variance is in the dummy sample, so we're just going to choose this t-test two sample assuming unequal variances and press OK. All right, so variable 1 is one sample and variable 2 is another sample. So we'll just click on this little button over here, and then we'll start with salary and we'll highlight this whole thing. Don't include the average, that's not part of the sample. Press enter. Okay, then we'll do the same thing with the dummy sample. We'll press this little button right here. We'll click on the dummy sample, press enter. Okay. Then it wants to know, it says hypothesis mean difference. So we're comparing our mean to 90,000. So I'm just going to type in 90,000. I want my output to have the label salary and dummy on it, so I'm just going to click here on labels. And the problem tells us we want an alpha of 0.05, so I'm just going to put that in, 0.05. That's the level of significance. If we get a number, if we get a p-value less than 0.05, then the difference is statistically significant. If we get a p-value greater than 0.05, then the difference is we say it's not statistically significant. Now I need to show where I want to put the output from this test. So I just click on this little button and I say, okay, I'll put it right here. And then press enter. Okay? Now if I press OK, it should give me an output. There's my output. Now I'm going to make this a little wider so I can see what we're doing. So you see I've got a column here for the salary sample, and I've got a copy here for the dummy sample. Since it's a dummy, I'm just gonna delete it. I just use that to fool Excel. All right. Then I can clean this up a little bit. Some of these things I need and some of these things I don't need. I could say t-test comparing Ohio salaries to national average. Okay. All right, so first of all, it tells me that the mean is 85,272. I already knew that. Okay, the variance is large. The sample size is 25. The hypothesis mean difference is 90,000. Degrees of freedom is the sample size minus 1. Here's the t-statistic. Now this is a two-tailed test, right? We wanted to know if it was greater or less. We don't care, just, you know, what's the chances, what are the chances that we would get a sample less than 85,000 if the mean was actually 90,000, okay? And so it's a two-tailed test, and here's the p-value for the two-tailed test. It's 0.042597. So since it's 0.042597, that's less than 0.05, which means it's statistically significant. Okay, so our answer to this question would be, because p-value is less than alpha, we can reject the null hypothesis. In other words, it's unlikely, it's statistically unlikely that we would get a sample mean of $85,000 or less if, in fact, the Ohio average school administrator salary was $90,000. Okay, then we can just, let me see. So our answers are, this is our hypotheses, and this is our p-value right here for a two-tailed test, and this is our conclusion. So there you go. That's a t-test in Excel.